in the past Monday, we just run our second exams. And the reason I choose to run that in this format is because I try to minimize the dependence on your internet qualities. So I have heard from some of you that now when you're conducting the quiz or the lab, the internet is always on and off. So I hope that by simply download the exam and put when you do the exam, you don't rely anything on the internet service. And I hope that this one can save you some work. But please feel free to contact me if you have different kind of the problems or the issue when you're doing the exam. Today we are going to continue our discussion of the chapter 9, which is about the magnetic field. So this is definitely not an easy chapters, but let's try to briefly review again what we have learned before. We have learned that if you have the bar magnet or the horseshoe magnet, some material in the nature will produce the magnetic field. And the magnetic field is produced by the magnetic poles, and we have north and south poles. And now we study that is, if you have the electric current, then the electric current also will produce a magnetic field itself. So the magnetic field here is produced by the current. But then we study that if you have the moving charge within another magnetic field, then the moving charge will experience a magnetic force. So let me emphasize that the magnetic field experienced by the moving charge is not the magnetic field produced by himself. So this reason people will get confused when they study these two different scenarios. And then we are going to start, we also introduce a very important concept, which is the Faraday's law. So Faraday's law tells you that if you change the magnitude of the magnetic field within some area, then you will produce an induced EMF, which is the induced voltage. And this induced voltage will produce an induced current. So I will say these three subsections are the part people usually are struggling with, and you definitely have to spend more time on that. And we also have studied how to apply Faraday's law to the daily life experience. And the example I give you is the motors. So let's try to refresh your memory. What is a motor? So motor is basically a device. You have a coils connected to a voltage device such that the current will flow from for example, the battery into the coils. And we have learned that from one of the right-hand rule. If you have the current passing through the wire within the magnetic field, they will experience a force. And the force experience will rotate the coils in the magnetic field. So what happens is that the device of the motor is you provide an electric potential energy. And this electric potential energy will be converted to the mechanical energy. So let's use the cars as examples. When you press the gas, you produce the current. So the current passing through the coils in the motor, and they start to rotate. And when the motor starts to rotate the car, actually what he is doing is that the tires of the car is rotating. So which means what you are doing is simply bring the electric potential energy to the mechanical energy, because now the car can move in translationally. But what is the generator? This is the second application of the Faraday's law in our daily life, and which is also very useful. But you will find out is in physics, they are the same as a motor, but in the opposite way. That's the reason I say the opposite. So let me explain what do I mean by the opposite. So in the motor device, you provide the electric potential energy, and the energy will be converted to the rotational energy. But if you have the generator, what happens is that you are the person doing the work, which is you are the person provide the mechanical energy. So you have to rotate the coils within the magnetic field. But still, if you are rotating the coils, you are ideally changing the magnetic flux passing through the coils. So depending on the angles, the magnetic field passing through the coils will sometimes smaller and sometimes bigger. And we learned that from the Faraday's law. When you change the magnetic flux, you produce an induced voltage. And this induced voltage will produce an induced EMF and the current. So you will actually provide the electricity. So you will actually convert the mechanical energy to the electricity. So that's the reason I say that now it will convert the mechanical energy into the electric energy via the coil motion, which means you rotate the coil. And the voltage and current you are going to produce will be alternating. What do I mean by that? So let's take a look about this slide. So when we're talking about the alternating current, it is because the voltage you produce through the generators actually it fluctuates, and there is a frequency of that. So you can see now at this point the voltage is positive and become smaller and smaller but still positive. But after this period of time, they will become negative and become more and more negative. So the voltage across the current, the circuit produced by the motor actually fluctuate. And there's a frequency for this alternating voltage produced. And this is actually equivalent to the frequency of the change of the magnetic field of the loop. Also, the same frequency will be the same as the current. So when the current changes also the directions with respect to time, we say it is an AC current. If it is a DC current, which means the current always flows to the same direction, so they should not fluctuate like this. So the current and voltage you provide or created in the generator is actually an AC current and voltage. And why this is important? So Faraday tells us that as long as you change the magnetic flux, you can produce either the current or the voltage difference or the mechanical energy, depending on which way you're doing. So later on, the Tesla and the Westinghouse, they use the principle, the Faraday's law, showing that actually the electricity can be generated in some device, and they can be used to light whole cities. So what do I mean by that? Let me try to explain. This is what we mean by the power productions. So in the power plant, we have different kind of source, a way to produce the power. For example, we have the dam, which we try to accumulate the water within the dam and produce a voltage difference. Let me say the potential energy difference. So when they release the gas, the water will flow from the point to the lower potential energy point. And the gravitational potential energy will be converted to the kinetic energy. So they were moving faster and faster and hit the turbine here. So when they hit the turbine here, turbine will start to rotate. So now this is the concept of the mechanical energy, which is the generator. So you rotate the turbine, and the turbine will rotate the coils within the generator. And because there's a magnetic field inside, so when you keep rotating the coils, then you can produce the electricity. So the electricity will propagate outward through the power lines and get into your house device. So what happens in the turbine is actually, let me say in the second examples. So you have the second device is not using the water, but use the coal as a device. So you first burn the coal, and try to heat the water. So when the temperature of water is above 100 Celsius, they will become the steam. So do you remember that? How do we define the temperature of the particles? It is the kinetic energy of the particles. So when the water becomes steam, they were moving faster and faster, and once again they hit the turbine, and the turbine will start to rotate. And how the turbine rotate is looking at these pictures. The steam were moving very fast as a particles hitting this part of the generators, and once they hit that, they will start to rotate. So which means the steam is doing the mechanical work, and the mechanical work will be converted once again to the electricity. And now this electricity will be passed through the power line to your house again. So you can see, no matter you are using the water dam or the coal as a source, the principle within the power generator are the same. But the way how you receive the mechanical energy is different. And this is a concept of the power productions. But when they try to transmit the voltage difference, voltage to your house, how do they do that? So now they have used the concept of the transformer. So what is a transformer? It is a device try to boost or lower the voltage. So now let's try to consider that you have two coils connected through the bar magnet, or just the iron bar. So the primary coils will be connected to the power plant. So therefore, the induced voltage will be flowing into the first coils. And you know that once they flow into the primary coil, they will produce an induced magnetic field. So this induced magnetic field will produce an induced voltage in the secondary coils, and this is your output. So which means that by using the Faraday's law, we can actually transmit or boost or lower the voltage through the different numbers of the coils.